Throughout the course of this year and next, the AIA Monterey Bay Committee on the Environment will center presentations around the 10 tenets of the framework for design excellence. Water is just one of the components of the framework. 2 months ago, we gave a talk on energy, and several more are being planned for the last 2 quarters of 2025. The learning objectives are as follows. We hope for this session to be interactive and to ask questions in the chat or live at the end of the presentation. We will also have staff members, possibly from several local jurisdictions, that may be able to answer specific questions as they relate to the permit process. The intent is that you use this information to pursue rainwater collection on your future projects and show those benefits to your clients. CJ, you can take it from here.
Thank you. Thank you, Libby. Let me go, if you just bear with me for a second, I'll go ahead and open up my presentation here. Can everybody see that? Okay, great. Again, thank you, Libby. My name is CJ Huxford. I'm here with ARCSA International to give a presentation on rainwater catchment systems and how they can be used as a resource. I am with a firm called Northwest Rain Solutions. We're based out of the Pacific Northwest. And so just a couple of things, because I'm from the Pacific Northwest, I'll do my best to illustrate some different systems and things like that in your area, as well as represent some of the codes and standards. I'm glad some other folks are going to be on. They can help fill in so many questions, specific questions as it relates to permitting. But just a quick note on that, a lot of the images and things that I'll show you are certainly not representative of all the different storage options and different types of systems that are out there. But what we're going to talk about, we'll kind of recap, or we'll discuss an overview of rainwater harvesting as a whole, take a look at a few different tank examples and things, but just keep in mind that we're not showing everything that's the different options and tank and storage options. So rainwater harvesting, what we're going to talk about is we're going to talk about the specific rainwater harvesting, the benefits, why we want to catch rainwater, what how benefit us, how benefits the environment, and then everything interplay between those. We're going to talk specific about rainwater catchment systems and the applications for use on the different things that you can use collected rainwater. Then we're going to talk a little bit about system capacity and how these systems can then scale based on what the application that you're using the rainwater storage for. And then a little bit on costs, more so just to kind of get a sense of a very basic system to much larger systems that incorporate a lot of other components. And then discussing a little bit about how we can integrate rainwater harvesting with our traditional water sources, whether that's a municipality or a well source or other things. Just in a look at how these systems integrate with those traditional water sources. And then we'll touch a little bit on codes and standards again, hoping some other folks might be able to fill in if there's some detailed questions, but we'll talk a little bit as it relates to rainwater catchment for non-potable purposes in California. So rainwater harvesting, why do we do it? And then who benefits or how do we benefit, I guess is a better way to put it. We can certainly benefit by collecting rainwater. Looking at it as every water or drop that you collect from your roof surface to then use in your garden area it wouldn't be water that you're using that's you're getting from your municipality, so that potable water. So using rainwater for those non-potable purposes that you're using potable drinking water like irrigation and things that take a lot of energy and a lot more infrastructure for that delivery method. So the beneficial water to plants, that note really touches on is a lot of municipal water is going to have a disinfectant in it, chlorine or other types of things that are used to help treat that water. Some of those types of components and those chemicals and additives to make that water potable aren't necessarily conducive for certain plants. So rainwater plants really respond to rainwater a lot better than they would with might be municipal water that has some of those additives and chemicals in it. And then rainwater can provide that offset. So if there are certain species or up here, one of the things we see is limited lawn surfaces or those kinds of things for stormwater applications. But if there are certain plant species that require a lot of water, if you were able to use that rainwater to offset that water that you would otherwise need to use for potable use, what kinds of options can that give some of your customers on different planting selections and things? And then, of course, every water, the water that you use or store from your roof, you're going to be offsetting that water that you're using municipal and paying for. And so there might be some money savings on that end of things, depending on how much you're storing and how much you're using. But those are just some of the basic benefits that we can get. Certainly that extends to ecological and environmental benefits. If you're mitigating the runoff that's coming off your roof that would otherwise be going over pavement surfaces or things that might collect pollutants and that kind of stuff that go into the stormwater system or off-site. That can help reduce stormwater runoff or pollutants in that stormwater runoff. And then, of course, also, in big storm events and things, if you're reducing that runoff that's coming off your impervious surface, your roof, and either using that at a later time or slowly releasing that, you can reduce that immediate rain or those surges of rainfall on that roof surface. And then a stored water source on site can be used in case of emergencies, whether that's an earthquake that might affect pump systems and things from your municipal water, anything that might affect the grander distribution system and the infrastructure. How can rainwater catchment on site be used in case of those types of emergencies? So really, that's touches on a few different things of the benefits of rainwater catchment, but certainly not all. So rainwater harvesting applications, where can we use rainwater catchment? I mentioned irrigation, whether that's drip irrigation or spray irrigation, you can use it for those purposes. Car washing or truck washing, even water features if you want to incorporate a rainwater catchment system that operates a fountain or a water feature. Those types of non-potable applications are relatively straightforward. And then, of course, you can use rainwater catchment or stored rainwater for other applications outside that I might have not listed, but then California notes that you can use stored rainwater for non-potable purposes indoors, like toilet flushing and laundry. And then, where permitted, and this may not be relevant, but using rainwater for potable drinking water or to offset the potable drinking water. And there and again, in emergency water storage, how can rain catchment systems be used in the event of a fire or another disaster or hazard event that would affect water distribution, or you might need water on site for other applications or other purposes in emergency situation. So systems can be designed, or you can incorporate these systems to have normal irrigation use, but always a reserve for emergency purposes. And then, of course, stormwater management and drainage control. If you have a large system that's offsetting those heavy storm events, how can that pull that runoff out of the equation for those flood and storm events? This image here or this slide here is representative, not great representative, but it is a representative of what you might expect for water demand for irrigation. And so ultimately, when you're discussing with your customers and communicating the feasibility of a rainwater catchment system, a lot of the questions are going to be, well, if it's irrigation, how much am I going to need? And these systems are really based on that storage capacity, and the bulk of the cost of the systems are going to be in that storage. And so, getting a real sense of how much irrigation demand and what the customer might expect of this rainwater storage system is a very crucial thing to understand early on or have that communication with your customer. And so, these numbers here can vary depending on the soil conditions of the area, how much exposure the sun gets, or the sun exposure to the sun a certain garden area might have versus another garden area. And then, of course, irrigation systems are designed often with the intention that there's an unlimited supply of water. And so, when designing a rainwater catchment for irrigation, it's very important to know what you're using that rainwater for, the species, the plants, and then what their demand is going to be during those dry summer months. With that said, this is not a hard set rule of thumb, but it's a good basis point. But the most important thing is considering those variables like soil conditions and exposure to certain garden areas. And then, of course, the method of how you're irrigating is really important to communicate. Drip systems will stretch your rainwater catchment out a lot more than a sprayed irrigation system. And then timing and is an automated system so that if you do get a little bit of rainfall or if the landscape may not need that water at that time, there's no sense in using that water. And so there's controllers and sensors that can do that to help stretch that water out for those irrigation purposes. And there's a link right there to a couple of different calculators. Some folks might have some better recommendations that they may be able to put into the chat. So rainwater harvesting and low impact development. I like to break this down into active and passive rainwater harvesting. What I mean by active is you're actively collecting that rainwater off the roof surface into a storage container to be used at another time. Think of passive rainwater harvesting more of putting that water directly into a facility or a system or the soil so that that water is either being managed by that facility or soils, or you're putting that water into the soil so that early in the spring, when those plants need that water, you're using less of your stored rainwater. So passive examples of passive rainwater harvesting would be such as like rain gardens or the bioretention and retention systems, infiltration, dispersion, even green roofs can be considered as a form of passive rainwater harvesting on some levels. But to differentiate those two things is a good way to communicate with your customer as to how they're going to evaluate the usability or the feasibility of a rainwater storage and how they can maximize that use. And so when looking at active and passive rainwater harvesting systems there, and again, active systems are you're actively collecting that water off the roof surface into storage. And then here's a couple of examples. The one on the left there, it is a series of above ground storage tanks that are linked together so you can get larger capacities within a smaller area if that's limited. And then below ground systems, same thing. You're actively collecting that water, putting it into a storage tank for reuse. Passive rainwater harvesting, here's an example of that. You'll notice that the downspout over by the front door is daylights into or empties into the upper part of that rock swale. Then that rock swale is the ground is shaped. It's hard to tell, but in a way where it will follow that swale and then it'll pool into those certain areas. There's some native plants put in there early on, but the concept is that you're putting that water into the soil. In this case, it's helping to manage that runoff, but also they're able to put the water into the soil. So early in the spring, that soil has got some moisture and water in it that the plants can use and uptake before you're having to actually pull on your active or your rainwater catchment system or your storage. So here's a great graphic from an old book, A Brilliant Mind. So runoff coming off the roof surface into a storage tank there you can see in the upper right. And then when that storage tank then overflows, this is how you can integrate the active and passive. When the storage tank overflows, it then goes down and then into a garden area. And then you see there when there's that overflows or that area can't take it, then it goes into another garden area and etc. Any way that you can implement this type of concept design within the landscape will help to benefit of course, all the plants and everything else because they'll like that rainwater, but you're also stretching that stored water use and then combining the active and the passive rainwater harvesting. Certainly, this is not going to work in every case, but having that concept design early on to be able to communicate that with your customer so that they get a better sense of how this system how you can maximize its usage throughout the year. So th this graphic here comes out of a recent white paper that ARCSA put together regarding Standard 63. And I like this graphic because it gives you the whole sense of rainwater catchment active use systems. So in every rainwater system, the requirements you'd have your collection or your roof surface. Then you would have your storage or your storage tank itself. You've got treatment for whatever level of treating that you're using that water for, how you're using it, and then the distribution system where that goes. And then, of course, the management, which is the most important part, maintenance. But I want to draw your attention here to the four-step process, which is there in the upper right. And this is really important for maintaining the best quality of stored rainwater, whether you're doing a small rain barrel or you're doing a much larger system that may be used for indoor toilet flushing or other purposes and applications, emergency use, is this four-step process. And that includes pre-filtration, which can basically be summed up to a pre-filter or some sort of mesh screening that's going to prevent organic debris and things from getting into your storage system. That pre-filtration might also include what's called the first flush system, which diverts the first bit of water that goes to your storage tank after a long dry spell. It's been documented that the most contaminants that build up on your roof surface is going to be during those long dry spells. So that first bit of rain is going to have the most pollutants and contaminants in it. So that's the application for the first flush. Then you'd have a calming inlet. Inside the tank, you'll notice the calming inlet. It's somewhat cut off there at the bottom, but it's basically running that inlet pipe all the way down to the bottom of the storage tank and then having that as either an upturned elbow or there are devices that can help smooth the water. The thought here is or the objective here is to minimize any stirring up of the sediment and other things that build up on the bottom of the tank surface. With that calming inlet, you're reducing the agitation of that sediment. And then you would have a skimming overflow, and you'd notice here once the storage tank reaches its max height, that skimming overflow helps to skim everything that would otherwise be floating at the top of the water surface, and that usually is pollen and things like that. So that's what that skimming overflow can help do to reduce that pollen. And then you'd have a floating intake or a floating outlet where you're drawing the water for whatever you're using that from just below the surface of the water where you'd have that the cleanest water within the storage tank is just below the surface. Those elements there, that four-step process is really important to maintaining the best quality of water in your storage tank, no matter what you're using it for. Uh, Catchment surface, moving on to the components of a rainwater harvesting system. Well, you start with your collection surface or your collection area. There's a good equation that we use that based on that roof surface or looking down on a bird's eye view of your roof area or your impervious area, how much water is coming off that roof surface, because that's going to determine how big of a storage tank you need and can certainly fill up based on your rainfall in your area. With 1 inch of rain on 1,000 square foot roof, how much water can you collect? Now, normally I have people raise their hand, but I feel like I'm going to just cut off my presentation if I go to see the chat to see who's raising their hand or throwing numbers out there. So I'll just give you the answer. With 1 inch of rainfall on 1,000 square foot roof, you get about 623 gallons of rainwater collected. That's a very important number to discuss with folks early on that are looking at rainwater catchment so they can get an idea of how much water they're actually collecting off their roof surface. Now, I've looked at a few different details or measurements of rainfall in your area, and it can vary anything from 12 inches of rainfall. And then as you get up towards the foothills or into the mountains, it can get up to 30 inches of rainfall, and then everything in between. It's extremely important to really know how much rainfall is coming down in your area, so that this number early on to discuss with customers is how many downspouts do they need to connect to their irrigate or their storage tank system, and then what they can expect from the different roof surfaces that you're conveying to this storage tank. So, pre-filtration, the first step within the four-step process. It's really important to make sure that you're minimizing the amount of organic debris and other things that are getting inside of the storage tank. That's what's going to create a lot of bacteria building up and things, and then foul the water or reduce the quality of the water in the storage tank. So every storage tank needs to incorporate pre-filtration, whether you're using a small rain barrel or a very large system. You need to think about not only organic debris from getting inside, but also mosquitoes and those kinds of things from growing inside of your storage tank, or even rats or those things from getting inside of them. So every opening and penetration should be managed either with a lid, or should be have a fine mesh screen or a mesh screen to prevent mosquitoes from getting in, and organic debris. So you'll see a couple of examples here in the upper left. You've got just a basic downspout filter that's in line off the gutter there. It comes down. It has an angled screen. You'll see some of that organic debris caught up on that. There's a lot of different filters out there. Some of them work really well in certain applications. Some of them work better than others. The most important thing is to know the mesh size. And then also, this is going to be the most important thing that folks are going to be having to maintain. And so if you locate these pre-filters like we have here in the lower left, way up high, that's a vortex filter up there. You have to think that they're going to need a ladder to go up and get to it. And so thinking about that long-term maintenance and the service on these systems is something that needs to be done early on and throughout. And what the homeowner is going to be expected of the maintenance of that. In the lower right-hand corner, you'll see this is a view of this particular pre-filter going, and the outlet goes into a below-ground storage tank. But the way these pre-filters are designed is there's a drop-down screen that goes down inside of them, and clean. And then as water goes through, clean water pushes out. And there's several different other types of pre-filters out there. Some have self-cleaning components. Others are a little bit more manual. But depending on what the customer what their expectations of the system, and their willingness to do this maintenance or have somebody come in, it's important to think about that. But also the quality of your stored water, what you're using it for. So a few different examples, but certainly pre-filtration can be as simple, if it's a basic system, as a fine mesh gutter screen, or sealed, or even the drop-down baskets that go in. Just thinking about how often they're going to need to clean that, and then of course making sure that it's going to be able to prevent anything from getting inside of it. So the simpler the better, the ease of maintenance, most important. Every system's going to have an inlet and you're going to have an overflow. You have to account for that storage tank reaching its maximum capacity at certain times. And so there needs to be an overflow, given that every inlet and overflow has to be sized the same. You have a certain amount of water flowing into that storage tank. You need to account for that same amount of water being able to flow out. And so if you've got a 4 or 6 inch or what have you going into your tank, or a 2 inch, you should have that same diameter going out. On the left side here, you'll see you've got your inlet coming in and through the top of the tank. Then when the water reaches the maximum capacity of this storage, then it goes out to the overflow, and then that slopes away. Inside the tank, this is another example of what you might see. These corrugated steel tanks, you can also do that overflow out the bottom of the tank too. but that picture on the right there shows inside a corrugated steel tank. You have your inlet coming down. That device at the very bottom is what is called a smoothing inlet, and that's helps reduce the turbidity that builds up. And then, of course, you have your overflow cut to height. So, different methods of conveying water. Thinking about how much roof area folks are going to be able to collect from is then going to ask the question of, well, how do we get all these downspouts to go to a specific area? There's a few different ways that you can do that. If you have multiple downspouts over a long spanned area, and the contour, the topography doesn't work where you can locate a storage tank, or you're not doing below ground, or that below ground may not be able to get gravity feed from all of the downspouts that you'd like to collect from, then you can either put that into a smaller tank and then pump that water to the storage tank, or you can do what's called a wet conveyance system. When we talk about wet and dry conveyance is what most people think of. When the rain comes off the roof, it goes into the pipe. It goes then directly into the top of the tank. When it's not raining, that pipe is dry. With a wet conveyance system, you're using gravity and hydrostatic pressure to push that water into the storage tank. And so if you have multiple downspouts along the side of the house, and it would not be it doesn't work within the aesthetics of the project to run downspouts across the side of the house, or you're trying to do an all passive system and not use any pumps or anything. A wet conveyance system can work in this manner. So you would have a sealed piping system that comes off the roof in place of your downspout. That sealed piping system needs to extend to the above the height of the inlet into the storage tank. And there are factors to think about with how much runoff is coming into these systems and going into it. But you'd be surprised with how simple these systems can be, and you can collect multiple downspouts using this method. So this would be a sealed piping system that then goes up and then feeds the top of the tank. Same principles when the tank reaches its max height, it overflows out into your overflow. This inlet is separated from that water line, or if you have a calming inlet that goes down into the bottom of the tank, you would have a vacuum breaker there. So you separate the inlet water into the storage tank. It's an example of a wet conveyance system, but the method of conveyance doesn't necessarily have to be a tank at each downspout. If you can think, and then within the project, combining your storage to a larger storage, you get a bigger bang for your a buck for larger storage tanks versus multiple small tanks. So thinking about that, and if you can incorporate this, that's one way to do so. So a basic dry conveyance system, these are several different tank examples, certainly not all, but just to give you an idea of a small rain barrel is in the upper left-hand corner there. You might have like 130 gallon or so. You see you've got your pre-filter goes into the tank. There on the lower left there, another example of a tank, and then the downspout runoff that can from this three-way valve here. Same thing, there's other tank styles. They call them slimline tanks. These are, instead of being wide, round diameter tanks, they're narrow. So those are slimline. Each of these examples are of a polyethylene tank, which is a common above ground tank. This tank here is a corrugated steel tank. We saw some pictures before of that and what that looks like on the inside. So you might have a bladder liner that holds or retains the water inside of there. There are other corrugated steel tanks where they put a spray-on liner or other things that aren't necessarily a bladder. But those are several different basic above ground tank options. Here's a picture of a wet conveyance system just to give you an idea of what this would look like in application. This system here, there's a water feature here. So the runoff comes down through this pre-filter, then it goes up, and then you'll see this is all sealed PVC system, and then it goes into this storage tank. Well, the outlet of this storage tank goes to just a float valve that just keeps that pond or that water feature topped off in the summertime because when it evaporates. A couple other examples of different style or types of tanks. Of course, simple is always the better, the best. If the customer wants to see the above ground tank or wants to see this storage tank, there are certain ways or examples that you can get, whether it's a slimline tank or you're painting these tanks or you're incorporating them within the building. Some folks don't want to see the tanks, and a lot of folks may not want to see the tanks. And so, if that's the case, certainly below ground storage tanks are an option, or being, hiding those tanks or putting them in a way where they're less noticeable, or going with like a corrugated steel tank that might look a little nicer along the side. Here's some examples of where folks have put these large tanks, storage tanks, behind a garage so they don't see them. They're again behind the garage, away from the road. So a couple of examples of larger corrugated steel tanks. So going from the small scale, these can go up to larger scale. So we saw a couple 100 gallons, the last picture there. These ones here are 5,000 gallon tanks, 10,000 gallons and bigger. Just a few more picture examples. A wet conveyance system when you're conveying water from far away. And then, of course, people hiding tanks behind the home and behind their shop and barn. These tanks don't also have to be set at the same elevation. These two tanks in the lower right corner pictured there are connected to a pump system in this green box, but they are connected both. So when one fills up, it overflows into the other, but they both feed this same system. And so you can do stacked on systems as well. Here's a few examples of below ground storage. If most people within their project want to first initially think, I don't want to see the storage tank, but I definitely want to have rainwater catchment. There are different below ground storage options. The cost for below ground storage is going to be more than above ground storage, just within the tank alone. The same capacity for a below ground storage is going to be a lot more than an above ground tank just because it requires a thicker wall, more structurally sound and things. And then, of course, that's outside of just the excavation and all the other things that need to be done. So, getting an idea early on if your customer expresses interest in rainwater harvesting or you really want to incorporate in your project, thinking about below ground, above ground, do they want to be able to see it? Are there ways to incorporate it within the landscape or hide it? Or can you do a below ground option? Getting to that very early on with the customer is extremely important because that's going to be a big factor within the budget. And it's really difficult when thinking about, how much storage capacity do you need based on a certain budget. And then by the time you're putting in a lot of different components, sometimes it can exceed what that customer may be willing to put forth within the particular project. So narrowing down that early on is really important. So if you have a below ground system, unless your irrigating or what have you is down slope of that storage tank, you're going to need to pump that out of the storage tank. You can do that. There's a couple of different very, very basic pump systems, but you can also use more extensive systems based on what you're using that for and how many fixtures you're delivering the water, distributing the water to. The upper left-hand corner there, that pump is the black unit right there. That has a pressure tank built inside of it, and so it's also a constant pressure pump. So for basic hydrants or basic irrigation systems, a pump like that can work really well because you don't need to take up a large area. It's also a 120 outlet, so it can plug right into a normal outlet. So certainly those types of pumps work really well if there's tight spaces or you're a single-use application or drip system. The picture in the lower left is another example of a constant pressure pump system. They've got pressure tanks built into them, so they're all one unit. These are different types of pumps than you might be familiar with if you've seen large pressure tanks with like centrifugal pumps and things like that. These are all built in. There and again, you can use other pump systems, but thinking about ease and then operation, and reliability, these are good and can be low cost options for some folks. And then, of course, the one there on the right is not the cleanest or nicest looking of pictures, but that's a submersible pump system that you would very common have in like a below ground tank. So you don't necessarily have to see the pump or hear it or have that to worry about incorporating that within your mechanical room or what have you for the application. But there are below ground pump systems, excuse me, yeah, submersible pump systems for those applications. And so extending that, using this for various purposes and understanding, the level of treatment or filtration that would be required for different purposes and applications. Here are some images of what you might see sediment filters and things that will filter that water for if you're using it for like a spray or a drip irrigation system. There are also other types of filters that can be used for that. As long as it meets a certain requirement of micron level, it's filtering out a sediment at a certain size. And that's 100 microns for indoor usage and most spray irrigation. But there are other filter examples that have that. These ones are cartridge filters here, but I wanted to show you these because the one on the lower left there kind of shows the whole system, but how you can incorporate these into little bump outs or utility units that are on the side of the house, and then cover them insulated and things like that. So you see here, there's a few sediment filters and a UV sterilizer. And then, so, basic filtration systems, they can go up to where you would include a UV for indoor usage for toilet flushing and things. And then systems that have much more control within them. You've got a full system with a UV and controller and other pumps and things that are doing a lot more. So these systems can be very basic and then scale up from there, even within the filtration systems as well. So rainwater harvesting, feasibility and costs. So communicating why rainwater catchment, rainwater harvesting systems to a customer, the benefit of those systems. Oftentimes I narrow down to these questions here to help get an idea of what that customer, what the particular project needs are, and then how rainwater catchment can meet those needs or be implemented in a cost-effective way. And that really is that early communication with the project manager, the engineer, the owner, the customer, is really getting a sense of what are they looking to use this rainwater for, and then taking those principles of how much rainfall you have in your area, what the available roof surface that you can collect from, and then what their expectations of the system is. Do they want to see the system? Do they not want to see the storage tank? Do they want to see some of the piping, the components, the pump system? Kind of teasing out those questions early on will help you provide an overview for a project that really would illustrate all of the different applications that particular project needs or that customer would like to do. And so it helps to address any cost issues and those kinds of things early on because it's being realistic about the scale that they can meet and what they can expect of that system. So what do they want to use the rainwater, the harvested rainwater for? Is it irrigation? Is it for a particular type of plant species? That's going to determine the size of the storage capacity or certainly help. And then, how are they using that as a delivery method? Do they want this to be an all gravity system or a pressurized system? And so then it might need a pump. If it's a below ground system, most likely it's going to need a pump. And then do you want to, of course, see the rain catchment and the different components of that? And so these systems must be cost effective per the customer's expectations early on. And so you can start with a basic system that's a gravity feed, like those rain barrel tanks that have just a hose bib right off of it that people, irrigate the plants right next to it or tomato plants and things. You can move up from that to mid-range systems that would maybe include a basic pump system. It might have a much larger storage. You're using it for perhaps toilet flushing or urinal flushing, some sort of indoor application in addition. So it's scaling that up. to the larger storage and then that pump capacity, and then going even to much a larger scale where you're looking at storage capacities in a larger volume. You might have some for emergency applications, fire use, using it for irrigation, and then other applications too. You would have some remote monitoring or those kinds of things that you can, whether it's the performance of the system or the level, so you can keep track of how much water you're using. It's really fun for some folks that like to track how much rain is falling and stuff, and then how much they're using that usability and monitoring can be fun. But of course, that's added. It doesn't necessarily have to have all of the bells and whistles and things like that. So added filtration and pump systems, multiple uses, the costs that go into these systems. Of course, at the end of the day, is going to be the big factor whether it moves forward or not. The biggest part of the cost in the tank is within your storage and within your tanks, and so really narrowing down as to what you what the customer expects of this system, what they're irrigating, and et cetera, and then the capacity of their roof area given the rainfall. Really communicating that early on will help you narrow down to which category or which type of system this particular project might fall in. Um, Costs vary. Of course, you can't give a certain number or range, but I fear I have. So I put a little note here saying roughly, and just this is more of a sense thinking about the different systems that we looked at today, and getting an idea of what your customer, what the particular project demands might need. If you're a basic gravity fed system, a rain barrel or something along those lines, you know, you're looking at the low end of this range here. But as you get into larger scale tanks, below ground tanks, that cost will and certainly will go up, especially if you're trying to meet a certain capacity. And then if you're doing below ground, you have excavation costs and other things. This all depends on, of course, on the storage, the site conditions, and things like that. But in your basic system, you can look at something perhaps within that range. And then within a mid-range system where you're then using a pump to then extract that water to send to a hydrant or an irrigation system, whether that's spray or it's a drip system. This is a much larger scale within that, but there and again, it's how much capacity you're looking to put and build within that system. Of course, you're not going to put a small 200 gallon or a 400, 500 gallon rain barrel that has just a basic pump for $25,000. But if you're looking at scaling up that storage capacity, running it to numerous hydrants or those kinds of things, or a full-on irrigation system, it could be within that realm. And so, and maybe doing a disservice by giving these ranges, but it's really to get a sense of when you're communicating this with your customer early on, or the project budget early on. Knowing what all of these things encompass so that it's not a surprise, but also you're able to track these systems, and then if other considerations come up, you can then scale these systems appropriately so they don't necessarily have to be thrown all the way out within the project, but you can use them to scale. So, integrating rainwater with our traditional water sources, this is a very old graphic pie chart, but I like it because the percentages are still pretty close, even with our efficiencies. And what I want to draw your attention to most is how much water people use for non-potable uses indoors. When I mean by non-potable uses, I mean toilet flushing and clothes washing. Most people don't drink out of the toilet or dip water cups of water, I hope, into their toilets, and then clothes washing, usually a closed unit. So between those two purposes within your household, it can be well over 30% of the water that you're using in your house. You're using potable water that's coming at a great expense and cost for energy and other things for non-potable purposes. And so that's something that it certainly is an application or something to consider during the rainy season when you might not be irrigating, but you may be putting in a pumped system if it allows and if your local jurisdiction allows and it's applicable within the project. Seeing how you can extend to multiple uses of your system in there. And again, it's a lot of water that we use indoors for non-potable purposes. So, 2025 California Plumbing Code. I've pulled a few different things here right out of the chapter 16. So just to draw your attention in regards to permitting the rainwater catchment system, here this note here is a permit is not required for exterior rain catchment systems used for outdoor non-spray irrigation up to a capacity of 5,000 gallons or a 2-to-1 ratio. It notes here needing to require electrical power or a system requiring that electrical power or makeup water supply would, I believe, need a permit. I'm not sure how that relates to plug-in pump systems, but maybe somebody can help us answer that. And then, of course, in regards to spray irrigation systems, here's a note there needing that permit. So when discussing or determining the type of storage or catchment system, this is what you can expect to need to meet or follow. There on the right, that table is the minimum water quality. This is right from chapter 16 as well for these different applications for the usage of rainwater and then what would be required from the treatment level. You'll notice there that car washing and subsurface drip irrigation just notes 100 microns, filtering out to 100 microns. But then as you get to like a spray irrigation system, you would need to incorporate a disinfection like a UV or something like that. And then so forth. When using that indoors, there's other requirements and things that need to be met as well. But all of this can be found in chapter 16 on this table gives you just a quick snapshot of what can be expected for the different types of systems. And then, of course, most recent news and information, California Senate Bill 597, I believe, has been put into law, and the bill aims to look at establishing building standards for rainwater catchment for newly constructed residential buildings. So, something certainly to be aware of and keep an eye on. Looking at these storage or these rainwater catchment systems and where they're moving forward it's important to know all of the different, of course, certain requirement standards, codes, and things, but how these can be applied and where they can be applied, so you can expand those applications and not be just focused on just irrigation. So standards and training, here's just, a note in the Universal Plumbing Code notes rainwater catchment systems. ARCSA has ARCSA ASPE ANSI Standard 63, which illustrates and provides direction and standards for rainwater catchment systems at any scale. And then the standard just came out, ARCSA ASPE 78 for catching and reusing stormwater catchment systems. The training for rain catchment systems, ASSE 21,000 series trains folks to be design professionals, installers, inspectors, and it's a fairly robust training series, and there's different degrees of those too. So even if you're looking to just kind of dabble or get a little bit of experience or understanding, there are different programs and things like that. So I encourage you to check out the link at the end, some of those options. And then I'm going to put in a shameless plug here for our conference coming up in Palm Springs, September 16th through the 18th, our annual conference where we bring folks lecturing on newest and greatest in research and information in rainwater catchment systems from all over the world. We'll have a lot of experts there too. So something to keep an eye out for. So just to recap, we talked about rainwater harvesting and why we want to catch rainwater, how it benefits the different applications that we can use rainwater catchment for. the system capacities and how they can scale up, a little bit on the costs, why we're trying to integrate rainwater harvesting within traditional water sources, and then codes and standards. We touched a bit on that. So with that said, I'll leave it to questions and leave this open, and I can leave this up for a minute. I don't believe I can see the chat quite yet. So if there maybe somebody can let me know if there are specific questions within the chat, but I'll leave. Yeah.
Okay, well, thank you so much for presenting this information today. I hope it was beneficial to the members here. Uh, as I mentioned at the beginning or in the chat, the intent is to present this to your client. And like I said, if your landscape architect isn't on board right away, these are things that you can ask your client early on. Just like a solar system, do you want to integrate this? And there is cost savings, given, as we know, the cost of CalAm water and such. Just to let you know, there's links here, AIA Framework for Design Excellence, if you want to read about that. And then if you're interested in joining COPE, please contact myself or Selena. Thank you so much for coming, everyone.